Here we go. Sorry, kids at home. This is Bellwork for the day. Let h be that antiderivative. H of 5 is pi. H of 2 is something. If the antiderivative of this is h, we call this thing h prime. They told me two starting values. The best way to find my starting value is to do start plus change. Okay, so our starting value is at time equals 2. Our ending value is going to be t equals 5, and we know what that is. It's pi. Our ultimate goal is to figure out where we started. Okay, we're trying to find h of 2. We said we were going to integrate from 2 to 5. That will tell me the change. And what am I going to integrate? H prime of x. That is what I'm going to integrate there. What am I going to have to do in my calculator in order to find it? I want to get this by itself. So how do I get rid of that? We subtract it. So in my calculator, I go to y equals. I typed in that thing right there, making sure I'm in radians. Okay, once I've made that decision, then I'm going to take pi, because that's what h of 5 is, and I'm going to subtract from that math 9, the integral from 2 to 5 y1. We type it in, we hit enter, boom, my answer is negative 5.866. It's B. Makes sense on what we did there. Start plus change equals end is always a theme here. If they told you a derivative and you want to know about h, in this case, we have to find the antiderivative, start plus change. Because remember, if you just do the antiderivative, all that's telling you is the change. You have to know where you started. Questions here? Today, we are doing some whiteboard review. Okay, so we're going to throw some questions on the board. You got a whiteboard in front of you. We're going to go through quite a few problems here. Okay, unless I tell you it's calculator, it's not calculator. The test on Thursday is both calculator and non-calculator, so we got to be ready for both. I'm going to throw a question on the board. You can work with your neighbor, work by yourself, see what you can do. There's your first one. Go. We're not doing too bad here. It says regions A, B, and C are bound in the graph. I went ahead and labeled all of them. Your goal here is to find the average value of f. This is a graph of f, and they want you to find the average value of f. If you want to find the average value of what's given, what are we going to do? Integrate. Good. 0 to 8, whatever my function is. And then I have to find the average of it. So it's 1/8 in the beginning. So 0 to 8 f of x dx, that means find the area under the curve. So that's 14 minus 16 plus 50. That right there is going to get me 48, but don't forget to multiply that by 1/8. 48 times 1/8, that would get me 6. Average value. You integrate and then divide by the bounds. Because that's average value. If I wanted to ask you to find your average test scores, you would take your test scores, you would add them all up and divide by 3, right? If I want to find the average value of f, I'm going to add them all up. I'm going to find the area under the curve and then divide by however many we got. Next one. Is this a U sub question? It can be. It's kind of an easy one to do U sub, but you totally could. What would your U be? X plus 1. What's the derivative going to be? 1. So it's kind of the easiest possible version. But it can be U sub. Go. Get an answer. Good. As I'm walking around, okay, here's what I noticed that I solved here. So du is just going to be equal to dx. That's pretty easy. If a student made a mistake here more than anything else, you didn't change your bounds. I need new upper and lower bounds if I'm going to treat it like a U sub problem, which you should. Okay, I need to find upper and lower bounds. So I'm taking 3, plugging it in. So my upper bound is 4. I take 0, plug it in. My lower bound is 1. So I'm going to reset this thing up. I'm going from 1 to 4. U to the 1/2 power. And then it said dx is just du. If I did it right, all my x's would cancel. Yeah, there wasn't any x's in the first part. There's no constants. So all we have to do is find the antiderivative. The antiderivative of u to the 1/2 is u to the 3/2. And then I've got to divide by my new exponent. So it's 2/3. I'm evaluating that thing from 1 to 4. So my setup, 2/3, 4 to the 3/2 minus 1 to the 3/2. 4 to the 3/2. That 2 means the square root. The square root of 4 is 2. 2 cubed is 8. 1 to the 3/2 is just 1 times 2/3. 8 minus 1 is 7 times 2/3, 14/3. Questions there? Next one, just show me setup more than anything else. You can use your calculator real quick if you need to, but just show me setup. What would the setup be that you would need here? Technically, this was a non-calculator question, but it would take you a few minutes. I just want to know setup more than anything else. Go. You guys did a nice job here understanding what's going on here. You've got velocity. So they told me velocity, and then they told me also with that velocity, x is 4 when t equals 0. What is the position? So they told me velocity, and they want to talk about position. What do I need to do with velocity to talk about position? Integrate. So I'm going to integrate velocity, and this is going to tell me the change. It's not going to tell me what the actual value is. That's going to tell me the change. Okay, so this is a start plus change equals end question. You got 2 times. Your 2 times here are 0 and pi over 2. So obviously my starting is 0. We're ending at pi over 2. So I'm going to integrate from 0 to pi over 2. Do I have a start? Yeah, my start is 4. We could do that. So when they originally set this question up, it was non-calculator. You would have had to integrate sine of 2t. You can do that. It would be negative cosine 2t, and then you'd have to divide by the derivative, doing some mental use sub there. But you could set that up, or in your calculator, the answer would have been 5. Questions there? Let's try the next one, some U sub, see what you got. Is this a problem of U sub? You can look up here and you see, hey, we got some sine or some arc sine. We got some arc tangent. Is the first thing you should always try, is it U sub? Is this one a U sub question? If yes, what would your U be? 1 plus 4x squared. What would the derivative be? 8x. Would the x's cancel then if it were 8x? Yes, so we can do U sub here. What would it look like on this problem if it were like arc sine or arc tangent? What would be on top? No variable, a constant, a 1, a number. Okay, and then remember the other thing is long division. If the top were like 3x squared plus 4x and the bottom was like x minus 1, that would be a long division problem because the top is greater than the bottom and it's not a U sub question. Okay, go see what you can do. U sub, we identified the U already. Work from there. The one thing I've noticed as I've taught this more and more, people love to pick natural log. Okay, natural log is what happens when it's 1 over u to the first power. If it's not u to the first power, it's not natural log. We love it. Okay, it doesn't always work. Okay, so I picked my u. I found my derivative. It's du over 8x. I substituted in. If I did it right, my x's are going to cancel. They did, so I'm on the right track. Do I have any constants? 1/8, so I'm going to pull that 1/8 out in front. Then I'm antiderivative of u to the negative 1/2. I add 1 to my exponent. Yeah, just plain. 1/2. I add 1 to my exponent, and then I divide by my exponent. So if I'm dividing by 1/2, it's like multiplying by 2. So in the end, I'm getting this one right here. It's 1/4. And then u to the 1/2, it's 1 plus 4x squared to the 1/2. So it's square rooted. Don't forget your plus c. Issues there? Stay with me here. We'll do a few more. Next one. See what you can do. Read through it. See what you got. All right. So there's a whole lot of words up there, but here's the key. Here's what you need. G equals the integral of f. This is a graph of f. If g is the antiderivative of f, what else could I call this graph of f? This is a g prime graph. Okay, this is g prime. Cool. Find the instantaneous rate of change of g. What does it mean you're doing if you're finding the instantaneous rate of change of g? The slope of g. What's another way of saying the slope of g? G prime. That's what it's asking for. It's asking for g prime at 3. All right, cool. 1, 2, 3. There's 3. What am I looking for on this graph right here at 3? The point, because this is a g prime graph, and they're asking about g prime. So the point is 4. Done. That's all it was asking for. You just got to kind of understand what's given, what are they asking for. Let's try the next one. On what interval? On what intervals, if any, is the graph of g concave up, and then justify your answer. See what you can do with it. This is an interesting one. Same thing happened last period. It took us a second to get going, but once we got going, we started figuring it out. Okay. On what intervals is g concave up? What derivative are we thinking about when we talk about concavity? Second derivative. What needs to be true about G double prime if we're concave up? G double prime needs to be positive. That's what concave up means. G double prime is positive. So keep that in the back of your mind. This is a graph of G prime. What am I looking for on a G prime graph to talk about G double prime? If I want to talk about the derivative of this graph, what am I looking for on this graph? The slope. Okay, because this is G prime. I want to talk about G double prime. I want to talk about the slope. And obviously, I want the slope to be positive. All right, so a few things you want here. First thing you got to say is link it. Okay, this is a question about G, and they gave me a graph of F. So I said F is equal to G prime first. My justification is G prime is increasing. Or in other words, it needs to have positive slope. When does it have positive slope? On this graph, it is from -5 to -2 and from 0 to 3. Those are the two places. I need a link, and why? Because G prime is increasing. Questions there? Just show me setup real quick on this one. Particle moves along the x-axis. It's given by that right there. That's your velocity. What is the total distance traveled from 0 to 2? Show me setup. Shouldn't take you long, I hope. A lot of us, if we go with velocity and we want to talk about distance, I have to integrate velocity. And obviously, I'm going here from 0 to 2. But if I integrate this is going to tell me the change in position. Okay, the change in position. That's not what I want. I want to know the total distance traveled. So what else do I need to do? Absolute value. And you got to make sure that you put those absolute values inside. Okay, they need to go in right there. Questions on that one? Let's talk some free response real quick. So I got a couple of free response questions I wrote up. We're just going to answer. Okay, I don't really need you to give me an answer. I want to see the setup. What would you do in order to set this up? It says the rate at which people enter an amusement park is defined by this right here. So this is the E of t. That is a rate. Okay, the rate at which people leave the amusement park is L of t. They're measured in people per hour. It's in hours after midnight. This is valid from 9 to 23. Basically, those are the hours that the park is open. At time t equals 9, no one is in the park. How many people entered the park from 9 a.m. to noon? Show me setup. What are they asking about in the question? We want to know how many what? People entered. Not a rate, but an amount of people. How many people entered? Which equation am I going to work with then if I want to know how many people entered? Just E of t. I don't care how many people left. That's not what the question asked. It said how many people entered. So I'm integrating. Okay, I'm integrating E of t. I want to go from 9 to noon. So 9 a.m. t equals 9. That's my starting time. So when is noon going to happen if 9 is 9 a.m.? 12. Boom, done. That will tell me how many people entered the park. Let's say that there were 50 people in the park to start the day. Would I need to take that plus 50 here? No, because they're already there. That's not answering the question. How many entered? They were already there. If I want to know how many people were actually in the park, I would. Same setup. Everything's the same. I said where. Sorry, I wrote it last question. Were the amount of people in the park increasing or decreasing at 11 a.m.? Just show me, talk with your neighbor here. Just talk for a second. Explain to each other what you would do and how you would find that out. Just have a conversation. Think about that. Talk with the people around you. How would you determine if the rate of people if the amount of people were increasing or decreasing? Let's look at it. Were the amount of people in the park increasing or decreasing? Okay. If we want to know the amount of people increasing or decreasing, what do I want to look at? The derivative. I want to look at a rate. If I want to know the amount increasing or decreasing, that is a rate. Well, cool. They told me a bunch of rates. Okay. E of t is the rate in. L of t is the rate out. So if I want to know what is the rate of people at 11 a.m., I want to look at that. Okay. So R of t would be the rate of people. I don't care. I just named it something. And what would that be? It would be E of t minus L of t. If I want to know what's happening at 11 a.m., what would I want to do? You plug it in. You would find R of 11. Okay. How could I tell if I'm increasing or decreasing? Positive and negative. If R of 11 is positive, then the amount of people is increasing. Okay, if R of 11 is negative, then the amount of people are decreasing in that problem. Kind of makes sense of what we're doing there? Yes, sir. Nope, because again, it says right here that T is measured in hours after midnight. So T equals 0 is midnight. T equals 1 is 1 a.m. T equals 2 is 2 a.m. and so on. So if I want to do 11 a.m., I want T equals 11 because it's 11 hours after midnight. You wouldn't want to find the derivative because if you found the derivative here, that would tell you is the rate increasing or decreasing. Okay, like a bunch of people just ran into line, and so the rate of people, it's going to increase. Okay, but it's to make sure you understand, you want to know the amount of people increasing or decreasing. So that is the rate of people. Okay, one more here, same concept, same setup. Everything's the same. The question then is, when did the amount of people in the park reach a maximum during the hours of operation? When was there maximum amount of people in the park? Talk with your neighbor. All I want to see is setup. You don't actually have to do the problem. Show me everything that you would do here to work from there. Go. So we were able to go through basically this whole story problem in just a few minutes by talking through it. When did the amount of people reach a maximum and justify it? You guys understand now that if we're talking about a maximum and justify, we're doing a table. My time is going to be T. To find the amount of people, I am going to integrate. When do people start entering the park? 9. So from 9 until whatever my time is. I don't know what the time is. And what am I going to integrate? Well, just like the one we said before, a lot of you use that. R of T is equal to E of T minus L of T. That is a rate of people. If I want to know an amount of people, I would integrate that. There wasn't a starting value, but if there was a starting value, I would add that in there as well, just like the penguin problem we did yesterday. When can maximums happen? Endpoints and critical points. So I know the endpoints are 9 and 23 because those were the hours of operations. Critical points are when the derivative is 0. So to find this number right here, you would take your rate and set it equal to 0. You would graph that in your calculator, E of T minus L of T, figure out when it crosses 0. That would be my value. We take those, plug it in, figure out when it's the biggest. Questions on how we set up that problem? That one, out of everything we did, those last 3 are probably the most important thing we did today. About 10